Good evening. Tonight we are going to start Chapter 6, and we're going to start on page 296. So everybody turn to Chapter 6, page 296. Please read with me as I read. Game Day Special. You volunteer to help out in the concession stand at your middle school football game. You must create a poster to display the Game Day Special, which is 1 hot dog, 1 bag of chips, and a drink for $3.75. Complete the poster by multiplying the number of specials by the cost of the special. Please do number 1 and then press pause, do number 1, and then press play when you're finished. All right, so your answer should be this. 1 times 375 is 375. 2 times that, or 375 plus 375 is 750, and so on. So go ahead and check your work there. Number 2. Before we do that, let's read here. In algebra, a variable is a letter or symbol that is used to represent a quantity. An algebraic expression is a mathematical phrase. It's going to have at least one variable, and it can contain numbers or symbols. So variable, just a letter or symbol, and then we use the word variable in algebraic expression here, and we can have numbers and symbols. Number 2 says, what algebraic expression did you use to represent the total cost on your poster? Let S represent the number of game day specials. So go ahead and try this one on your own. All right, and that's going to be 375 times S. So the amount you spent per special is 375, and then times how many there are. So if there was 10, we would do 375 times 10, and we would get $37.50. All right, now number 3 says the cheerleading coach wants to purchase the special for every student on her squad. So use the equation that you got for 2, the 375 times S, to solve number 3. So where the S is, where the S is, you'll plug in 18. So go ahead and do that now. When you do 375 times 18, you will get $67.50. So that's how much the cheerleading coach is going to have to pay if she wants to buy everyone on the team special. All right, let's move on to page 297. Please read problem number 2 about the graduation party and number 1, and go ahead and try number 1. Do that now and press play when you're ready. All right, you should have gotten something like this. It wants G to represent the guests at the party, and we know that it costs $40 per guest, and just to rent the hall, it's $105 plus 40G. You could have also written 40 times G plus the 105. If I said let F represent the guest, then there would be an F there. But since it says G, you need to have a G times the $40 and then plus 105. You can either do 105 plus or 40G plus 105. Both of those would be fine. Let's see number 2. Determine the cost of the party for each number of attendees. Show your work. So it tells us 8 guests. If 8 guests attend, I'm going to use my algebraic expression. I'm going to plug in for my variable, which is 8. So I would do 105 plus 40 times 8. So 40 times 8. 4 times 8 is 32. And then I'm going to add a 0. So I have 320. And then plus, if I want to have the party, I need the reception hall, and it was 105. So 105. And that would be a total of 400 and what? Go ahead and write it down. $425. So just for 8 people to come, it's going to be $425 because there's a big fee there to rent the hall. Let's try letter B. Letter B says 10 guests. So now where your G is, plug in 10. So 10 times 40, 400, and then 400 plus the price to rent, 105, be 505. Go ahead and finish problem 2 and press play when you're ready. All right, so we have C here, and you should have got $585. So now let's move on to the next page. We're going to go to page, give me 1 second. All right, page 298, still on chapter 6.1. Let's look at problem 3. In problems 1 and 2, you work with two expressions. You worked with the $3.75 times your S, and then the first expression just had a variable, and then the second one we did had both numbers and variables. So we did 105 plus 40 times the G. You evaluated those expressions for different values of the variable. To evaluate an algebraic expression, you replace each variable. So for the S, we said like 18 cheerleaders wanted to buy it. And for the G, we did, okay, well, 8 people are coming to the party. So we replace each variable in the expression with a number, numerical expression, and then perform all possible math operations. And we did that when we solved for 1 and 2. So now let's practice evaluating some expressions just without giving you like, okay, well, there was a snack or this many party. I'm just going to give you the math problem. So x minus 7, and I want to do that for x equal to negative 8. So where the x is, I would plug in negative 8. So I have x minus 7, and then I'm going to put the negative 8 where the x is. So I'll do x minus 7 equal to negative 8 minus 7. And so just a helpful hint to remember, if you haven't heard this before, is KFC when you're subtracting. So keep, flip, change. So I'm going to keep negative 8. I'm going to flip the minus to a plus, and then I'm going to change the sign here. So the negative 8 minus 7 is the same thing as negative 8 plus negative 7. So keep, flip, change, and that would give me negative 15. Whoop. All right. I want you to go ahead and try the rest of A. Do that now. Press play when you're ready. All right, you should have gotten negative 18 and then 9. All right, B, negative 6y. Well, whenever a variable is next to a number, that means we need to multiply those two together. So first we're going to solve the first one for negative 3. So where the y is, I'll put negative 3. I have a negative 6 times a negative 3 equals 18. And I just want to remind you that a positive times a positive is always positive. And then also negative times a negative is always a negative. And those are really big. Let me make that. Just put that in the margins of your notes. So a positive times a positive is always a positive. A negative times a negative is always a negative. And then our last one is negative times positive is always a negative. So since we're doing negative times negative, it's going to be a positive. I'm sorry about this. I meant to put a P here. Thank you. Okay, so negative times negative is a positive. Positive times a positive is a positive. And then the only time it's going to be negative if I had negative 6 times a positive 3, but I don't. Or you could do negative 4 times positive 3, that would equal negative 12. So those are our 3 rules there. Go ahead and try the rest of B and press play when you're ready. All right, you should have gotten 0 because a negative times 0 is just 0, 0 times anything, and then negative 42. A negative times a positive is a negative, and that's what we said right there. Letter C. So first we did subtraction, then we did multiplication, and now we're doing a 2-step equation. So whatever B is, we're going to plug in. So B is negative 2. So, and I always want to do order of operations, so multiplication comes before subtraction. So I'll put the 2 there. 3 times negative 2 is a negative 6, and then minus 5. So I can do my KFC if you want, since we're subtracting. Keep, flip, change, negative 6. So I keep the negative 6. I flip the sign. I change that to addition, and then I So flip change to -5. -6 plus -5 is -11. Go ahead and try C on your own and press play when you're ready. And I also want you to try D and then check your answers for C and D. All right, you should have gotten 4, 22, -28 and 1/10, -1 and 1 and 6/10, and then 19 and 6/10. On the next page, we're going to be completing the chart. So I've gone ahead and completed this chart for you, letter A, and I want you to finish the rest of your chart on your own. But here, let me show you what this means. So my equation is -2h minus 7. So I did -2 times h, and this case the h is a 2, so I'm going to do -2 times 2, because I'm using this equation right here, -2 times h minus 7, and then multiplication comes first. -2 times a positive 2. A negative times a positive is going to be a negative. 2 times 2 is 4. -4 minus 7. Keep flip change. Keep flip change. -4 plus -7 is -11. So good. We know the book has mistakes all the time, so you try the next 3. Make sure the book is right. I want you to finish number 2 on your own. I also want you to do page, so that'll be all of page 299, A, B, C, and D. I've showed A for you, and then I want you to complete page 300 and 301 as well for homework. So if we look at the next page, it'll show us, oh, 1 second, problem 4, and it wants you to solve for -2, -3, no, +2, x equals 2, -3, 1/2 or 0.5, and then -2 and 1/3. So for A, B, C, and D on this page 300, you need to plug in for all of those. So first I would plug in the 2, solve, get -6, then I would plug in the -3 and get a +9, negative times a positive, negative, negative times negative, positive. And then next you'll plug in 0.5 and so on. You'll do this for A, B, C, and D on 300. On 301, you will plug in -7, 5, 1.5, and -1 and a 6. So on A, when it says 5x, you'll do 5 times x. X is -7. Answer. So it's kind of like A, B, and C, and then it has 4 parts. A, B, C, D, or maybe this is 1, 2, 3, 4. So then the next one I would do is 5x. Well, my next x is 5. So 5 times 5 is 25, and so on. So make sure tonight for homework we do 299, 300, and 301. Have a good night, and we will see you tomorrow.